So what was A from the calculator? If you don't remember, then go and punch them in again. What was the calculation, Jorge, of A? What number did you get?
I don't write it down, sorry.
It was 0, Jorge, right? And B was 2. And this is known as the intercept, y-intercept. And this is known as the slope. So the 2 is capturing the proportional relationship between x and y. It's a positive 2, so it's telling you the direction. A is telling you the y-intercept. In this case, it goes through the origin. And I put a hat on the equation to denote the fact that the line is not a mathematical line. The line does not go forever. The line we visualize here is this one, and it only exists close or around in the range of the values seen. I'm gonna miss it. Okay. Notice I'm just specifying. I mean, I can't it should go right through them. Let me make these a little bit bigger so it forces it. Okay, so they fall exactly on that line. So this line is known as the best fit, line of best fit, prediction line. Now, because the points fall exactly on a line where the R is 1, that's something else we got from the calculator. To get this line, all I would have to do is use the techniques of high school mathematics to find the slope of the line, and then I could get the intercept, which ends up being 0, and make the equation of the line. But I put a hat because the data and the interpretation for prediction only exists in the range. I shouldn't be using this line outside of this range of x's, okay? So this is the range of prediction. In general, the data don't fall in a line. In general, the data are scattered. That's our scatter plot. So it's not perfect. R won't be exactly 1. What would be the R in this case? Less than 1, right? But it would be positive. It would be positive. And then the line that fits best could be that one. But what defines the line of best fit? Does anybody know? Can anyone explain it?
Isn't it the line that captures like the most points, or where the tendency where the most points are close to the line?
It kind of, but something about the points for sure. The line floats between the points such that the distance from the points above the line, if you were to add them all up, would be equivalent to the distance of the points from the line that are below. In other words, it fits closest to all the points. Now, if you think back to the last class, there's something else that sounds like that. What's the value that's closest to all the other values in a data set? What is the value that's closest to all the other values in a data set? What is the
It's the
center
mean.
of gravity of a data set?
Yeah, it's the mean of
Very good. The mean, right? So you guys remember the mean is closest to all the points, and the way that the values that are higher than it, their amount and their distance from the mean, and the values that are below it and their distance from the mean and their the amount and distance from the mean are perfectly balanced. It's like a relative zero. It sits right in the middle of all the data. So that line fits in two dimensions between all the values. So actually on this line, the mean of the x's and the mean of the y's will fall on this line. Interesting enough. And the slope of this line will be found by this equation. Now, the slope of this line also will be found by this equation, but you probably don't have to to make this calculation for the slope, you have to get three things: sy, sx, and r. That's a lot of calculations if you're doing the manual, right? So you probably won't go through that length. You just do it the old high school way if the values fall on a line. That's why it's important to draw the line first. Or the scatter plot in this case. And here, this line that I fit here, I mean, I just drew one, but the idea of the best fit line is the one that sits closest to all the points. So I'm having some organizational issues here. All right, so this line where they fit perfect is a better prediction line in the, like, in reliability than this one. Would you agree? So if I use this for prediction, I'm probably right if I use the line to figure out values that I haven't observed, right? But in this one, there's some volatility here. Now that's really important. That's why we don't just want the equation of the line. We also need the R for reliability. And R is in the equation of the slope, but to understand the value or reliability of this estimate, we need the R. So those are two different things. R is the strength of the relationship. B is the slope relationship. How they fall on the line and how they're used to predict one from the other. Okay. Any questions so far? Again, here, the equation only exists around the data. If I try and make a prediction outside of the data, it's risky. Well, I say risky, but it's not recommended, right? Because you don't really have the statistical foundation to do that, because the relationship may change outside of the range of data. It might be a different relationship. So let's look at the slope. What is it? Let's talk about what the slope means in the context of our problem. It's not a coincidence that I made X the S&P 500, okay? So the way that we're going to do this in Unit 5 is the S&P 500, or some measure of market performance, will be on the X-axis. So the S&P 500 is a composite index. It ties or it puts together into a estimate the top 500 performing stocks on the stock market. And that changes, it fluctuates. There's different companies that fall into that. And they're using the market capitalization, that is the value of outstanding stock, and combining them into an index. And this index reflects the performance of the economy. Okay, so it's like a proxy, it's a variable that tells us how good the economy is doing. So that's how we're gonna refer to this as the market returns. And you're gonna see it's always gonna be here, X. So this is the market returns. And BCE is any stock. It's not always going to be BCA. It can be any company. And this is the returns, which we're going to talk about when we get into Unit 5, how I calculated these. These are the returns to this stock called BCE. Or the company's name is BCE, Bell Canada Enterprise. So now, with that information, can you tell me how I interpret a B of 2? Can you guys put it in words for me? You can write it in the chat, or you can tell me, what is B equal to? What does it mean?
Well, if we look at the formula, y equals a plus b multiplied by x, with a b of 2, it's 2 times x.
Okay, but I want you to tell me, give me a sentence. Thank you for the answer. Try and give me a response in the context of the data. So we're going to call this market returns, and we're going to call this BCE returns, okay? So I'm going to describe it, and then I'll give you another chance. So B equals 2 means 2 over 1, or change in y over change in x. And I'm going to start my interpretation from the x. I'm going to say a 1% increase in market returns how will that influence BCE returns?
It moves 2%.
Right. So for 1% increase in market returns, BCE returns increase 2%. Can you guys see my writing? I gotta move it over here. So that's how we'll interpret, all right? So write that down. So 1% increase in market returns correspond to BCE for BCE returns to increase by 2%. What if the market returns increase by 5%? What happens to BCE returns?
Increases by 10%.
Exactly. Okay, so we're just using the slope, we're seeing the proportionality, and it seems that BCE returns are sensitive to market performance. So in this way, the slope, or what we're going to call the beta, is a measure of sensitivity of a stock's returns to market returns. Now the data is all positive, right? And like I said before, we shouldn't extrapolate. We shouldn't try and make predictions outside the range of data. But if we did, just to make the example, if if the market returns dropped by 5%, what would happen to BC returns?
It drops by double of that. In this case, would be
And
negative.
negative, right? Okay, so in that way, we see that this is not a great thing. But again, the data is only in the positives. Maybe there's different relationship in the negatives. But if we just took B by itself, this is very sensitive and risky. It's a risky stock in that sense. Obviously, it looks great in the positives, but this is a risk. Okay, so with that explanation, I'm going to show you. Although if the data falls on a line, it's very easy to get the slope. In general, the data does not fall on the line. It falls on a scatter plot, and you need to use statistics to estimate the least squares prediction line and get the slope from there. Okay, that's what's going to happen here. Now, I'm not going to expect you to, well, I mean, you could get the line because you know how to get it out of your calculator, right? So I can't expect that from you. You could get me the line. And you should be able to do it manually too, but I'm not going to harp on that. I'm really interested in the interpretation. So let's see. I want to call your attention to B. So B is calculated in general when you have points that are not on the line, which is most of the time, by R SY over SX. Notice, just like R has the same sign as covariance, we talked about that, because the standard deviations will always be positive since they are the square root of a variance, that will always be positive. So these will have the same sign. Covariance can be negative. If so, then the R is negative. In the same way, R and B have the same sign because, again, SY and SX will always be positive. So R tells you the direction and strength of the linear relationship. The B tells you the proportional relationship and the direction. It'll give you the same sign. I refer to this as risk for two reasons. It helps you remember the formula, and I spell it this way, to help you remember the formula. And you can put this formula, and you should put all these formulas onto your formula sheet. But you're going to take R, you're going to use the SY first and divide by SX. And this is the result of a optimization, like by calculus. This result arises from getting that least squares prediction line, which is actually calculated as minimizing the squared residuals. Residuals are those distances from the point to the line. So this is not a statistics class, so I'm not going to get into all that. We're just going to use the results, right? So in this way, we see B, the slope that comes out of your calculator for when you do two variable calculus, because two variable statistics on the calculator. Our calculator calculates two variable statistics. And it tells us how risky the asset is relative to market returns. The asset's returns are to market returns. Okay, I think I've said enough about this. You should be able to get all these. Now, if you have R from your calculator, do you guys see how you can get covariance if I asked you for it? How would you get the covariance from the R? So this one, you can get out of your calculator R, SX, and SY if you put this data in the calculator. So do you see that you can compute covariance as well by taking, sorry. So if I ever ask you in any of the problems, you need to get the covariance for X post data, you just got to get the R, the SX, and SY, multiply them together to get it out of your calculator. Okay? think that's the easiest way. All the other statistics you get immediately out of your calculator. So this can save you a lot of time knowing how to enter it. If anybody missed last class, watch the video about entering this data into stat mode. All right, so this is ex post data. What if instead the data appears like this? In this case, a distribution of possible outcomes has been generated based on ex post data, fundamental analysis of the BCE returns, some perspectives of the firm, so using together with projections of the state of the economy. All that's been put and given to you in this table and simplified it into 3 possible states of the economy. Either the economy does great, it does just, you know, like an average performance or normal performance. And the third, it could be in a recession, so bad. So that's great, okay, and bad state of the economy. The most likely of these is which one? Which one is more likely?
Normal.
Normal has a higher probability. It's more likely. Next is the boom state. And third is the recession. So it's looking up, looking all right. So now what we see here are the returns for the market and the returns for this company that have been estimated. This data is going to be used as though it is a predictive distribution of outcomes. Now, this is actually quite simple. I'm just giving you 3 outcomes. This is a discrete distribution, okay? I could give you a distribution as a formula, but we're not going to do that in this class because you guys, I don't assume calculus, and I don't put that on you at this level. But that's what you could do. This is actually simple. As complex as it looks and as scary as all this looks, this is actually simple. 3 states of the economy, discrete distribution. And what we're going to compute up here, I called these sample statistics, right? What am I going to call these? All these Greek letters. How am I going to refer to these? Well, because these are the only possible outcomes. Sorry, these are the only possible outcomes. Well, in these states of the economy with those probabilities, we're going to refer to this as a population distribution. And these are population parameters. Okay, so that word is reserved for characteristics of the population using population data. And when we talk about parameters, we use the Greek letters. So that's why we have Greek scary letters here. But you shouldn't be scared. It's equivalent to what we did above. The difference is going to be that it doesn't come out easily out of your calculator, not the calculator that we have. If you buy the HP 12C, it will do it. So if you're really in the market to do the CFA exam, you might want to do that. But I'm going to show you how to do this pretty easily on the calculators you have, okay? So there's 2 reasons to buy the other calculator. One is weighted. These are known as weighted statistics or weighted, I'm doing parameter calculations, but weighted statistics. And for the IRR, right? It does those calculations well, better than the one you have. So what is this? This is the mean. We're going to use mu because that's the Greek letter M for mean. And it's a weighted mean, a weighted average. Let's start there, and you're going to see this is not as scary as it might look. So I'm going to take this data here. We're going to calculate, let me make this. We're going to calculate the mean. The mean rule, the weighted mean is that I have to pre-multiply every value by the probability and then sum the values up. So I can do that here by multiplying 0.4 times 14, putting the number there like that all the way down. So we could do that. I'll let you guys do that one. That one's an easy one. So I'll show you the steps. So let me clear my calculator. But remember, you have to clear work before you begin the worksheet. Take 0.4 times 0.14, and that's this number. You can store it. .5 times 0.08 and store it. Oops, what happened? Oh yeah, okay, well, 0.5 times 0.08 and store it. And then 0.1 times 0.04 and store it. And then you add them all together. Okay, so let me know if you got that, 10%. So that's the average. The weighted average is 10%. Now, if you can you get that? And then I'm going to show you how to do at least this. You can actually use the calculator for the weighted mean. Are you ready? I'm going to put all the data into my calculator in stat mode with this as my X and these as my Y, not to be confusing, but that's what I got to do. So I'm going to enter the weights in the X and the returns in the Y. Note, just to be to check, the weights must sum to 1, right? You make sure it's a proper distribution, legitimate distribution. So I put them all in. Tell me when you've got them all in there. Where's X01? Oh, you have to hit second data, Jorge. Second data, second there. Anybody else? So I'll wait for Jorge to enter everything. So what we're going to get out of here is the weighted average if we use the arrow up, go up. Sorry, what happened? I have to hit second stat first and then go arrow up. And that will give me the answer quickly. Should I do it again? Nicole, how are you? Are you okay? ¿Está bien? All right, so should I repeat that or? Okay, so here we have what I found is the weighted mean of X. I'm going to ask you try and get the weighted mean of Y, and then I'll show you how to get it. Do the same thing with Y. Okay, Jorge, you want me to repeat? I will repeat with, okay, I'll do it with X again. And then we'll do it with Y. So I'm going to put the values of P into X, 0.4, enter down, and then I'm going to put the values of X down here into Y, so 0.14. And then I'm going to put 0.5, enter down, and 0.08, enter down, and 0.1, enter down, and 0.04, enter down. And then I'm going to ask to compute statistics. Oops, what happened? This should be 0. Ah, what happened? 0.4, 0.14, 0.5, 0.08, 0.1, 0.04, and then this is not what I want. I think I have to do it over because it's gonna think I have another value in there. Okay, so if I hit second stat and scroll up, I get the 10%. Because this statistic is a product and I've used taken advantage of this statistic that appears. There's a lot of statistics that get calculated here, but I just want this one. And that'll give me the 10% easily. So now I'm going to do it for Y. Well, let's see who's got Y for me. Did anybody calculate it?
I got 22.22.
Wonderful. Let me do it for everybody else. Okay, so let's do it together. So I'm going to put in these values for X and these values for Y to get the mu of Y. So I'm going to put in 0.4, enter down, with 0.3, enter down, 0.5, enter down, with 0.18, enter down, 0.1, enter down, with 0.1, enter down, and I'm going to ask for the statistics and then scroll up. Yeah, 22. So that's pretty easy, right? So I got also mu Y equals 22%. Okay, so all we've done so far is this, the means, X and Y, and we have to get the rest. So let's keep going. How do you propose we calculate this one? Again, there's no easy way to do it. It's going to be manual or using your calculator and this product. statistic. Sum of the products. So what I'm going to do, okay, well, I'm waiting for you guys. So let me know once you got 22%.
Second stat, right?
That, mhm. Who has not gotten it yet? Who has gotten it? No one? Just the Ariel? Emilio, you okay?
I think you took the BCE results, right?
I took wait?
You used the BCE column to get to the 0.22.
Exactly. I use these two columns. This one as X and this one as Y. Yeah. Want me to do it again? Yeah, you guys have to do it because the next calculations I'm going to do it again. I'm going to repeat the same process. I need you to get it now because it's just going to be drawn out. At some point, you'll realize, you just need to do it. All right, I'm going to continue. I'm not hearing from you. I'm assuming you're working on it. I don't really want to start until a few of you at least, other than Yariel, got it. Okay, I'm gonna look now at the variance calculation. How can I do this in an efficient way? Imagine 3 brackets because there are 3 data points. And I have to take the deviation from the mean, square it, and in this case, pre-multiply. It's just like the weighted average because remember, the standard deviation is the square root of the average of the square deviations from the mean. Let me go back to the weighting thing, okay? So the weights here are different. That's why I have to use this formula. This is a general formula for average. But these also have weights from the earlier problem. What are the weights of each of these? I mentioned that every value provides equal amount of information. And equal amount of information, equal amount of weight. Notice in the formula here, there's also a weight here, but it's equal for every value. So there's 5. how can they be equal? Well, each one is 1 divided by 5. That's what this is for. So there's a weighting going on here, but the weights are the same. That's why the formula looks different. Really, this is 0.2, 0.2, 0.2, 0.2 for each data point. So you could actually use this formula, but it doesn't make much sense because it's easier to divide by 5 at the end. Okay, I just made that point that the weights are different here. That's why we have to use this version of the formula. But it's a general formula. We could do the same thing with the data above, where the weights are all the same, or 1 over 5, or 0.2. So what am I going to do for the variance? For the variance, I'm going to put the means that I calculated here. So let's do the variance of x, which is going to be the square root of this. So think about Excel. This is how Excel would do it in columns. I'm going to put the column of the mean. The mean was always, you're going to put always 10%, right? Because that's the mean. And then deviation from the values. What were the values? The values are here. So I'm just taking this column and putting it here. Actually, maybe I'll do that. Oh, I hate when that happens. So imagine me dragging this over here. I'm just going to copy it as decimals. It's better than putting percent. And yes, I have to do it somewhat manually, but I'm going to still take advantage of the technique I just showed you in your calculator. And what we're going to do is get these and put them into storage. And then put them into storage, and then you're going to use the method that you used here with the product statistic. Okay, so get these into storage. .14 minus 0.1, square it, and store 1. 0.08 minus 0.1 equals, square it and put it into storage. 0.04 minus 0.1 equals, square it and put it into storage 3. So I have recall 1, recall 2, recall 3. I'll make a note. Let's do it again. 4 minus 0.1 equals square. So this one is in case you make a mistake. Okay, and now what I'm going to do is use the method in stat mode to put them in. First, I'm going to put these in as x. And I'm going to put these ones in as y. And ask for the multiple, the sum of the multiples. So I'm going to put 0.4, enter down. And in y, I'm going to put points. Oh no, I'm going to recall 1, enter down. In 2, I'm going to put 0.5, enter. And then I'm going to put recall 2, enter down. And then 0.1 as my third. And recall 3, enter down. And then I'm going to ask for statistics and scroll up. And that's what I get. I think it's wrong. I don't know. I'll have to try it again. I think I had a different answer last time. Yeah, I did something wrong. I probably made a mistake last time. Oh my goodness. So I was at 0.4 and then 0.0016, 0.5 and recall 2 and 0.1 recall 3. And ask for statistics and scroll up. And then you have to take the square root to get the standard deviation. So you guys have some practicing to do. This is going to be your statistics practice in finance, which is required. The answer for the standard deviation of x is 0.034. I prefer to write it like the variance. And then I'm going to show you. I have all the answers on the platform. Any questions? So you should be able to make all the same calculations we made above. Remembering you have to pre-weight all the possible alternatives here, possible states of the world. We use the Greek letter S for sigma, or sigma for S, standard deviation. We use the Greek letter rho, which is R. It's not a P, it's an R for correlation coefficient. And we use beta for the slope. You can see on the platform, I've made all these calculations. You can do this in Excel for practice, but for the test, you're going to have to be able to do this manually. So you should practice manually. Let me show you on the platform if you don't have any questions. What I'm referring to. So here on the platform, you have all the statistics review documents, and here it's the solutions from this document that we're reviewing right now. These are the solutions for the X post data manually calculated, where we got a slope of 2 and a correlation coefficient of 1. And here are the solutions. Well, I called it just to clarify. You see, it says ex ante risk and return. So these are the solutions manually. I tried to put them evenly in columns. I don't know. They fell out of the columns, but you can see that's what we're doing right now. And this is our calculation. So I calculate the means, the variance, the standard deviations, and the covariance and the slope. And what do you guys see here? That this data, what you stare at it, can you see a pattern in the data like we did for the ex-ante data? Can you make any statements about the
You
relationship?
don't see the same as the other data.
You don't see it as the same because each one has different significance, and it's hard, mentally, a human mind to look at that and make sense of it. But when we put it all together, look at this. This would be considered to be perfectly positively correlated, even though you can't see it, and the slope is 2. So after all is said and done, your R and your B are going to have the same value. Okay. So what I want you guys to do is make sure you know how to make all these calculations, confirm that you can do it for this data set. And in a test situation, and even in the video, even in the notes, for the lecture notes that we're going to cover in Unit 5, I'm not going to use more than 3 for ex ante. Okay, but you have to understand the difference of the data and the difference of the statistics that you can calculate from the data. And these are going to be parameters. Oh, it's funny, I put X bar. But these are actually, this is mu X, mu Y. I think I was trying to relate to you that it's just like the mean, just like, because I could put these symbols here, but I'm emphasizing the Greek letters to remind you that it is a parameter. It's not just a statistic. We call it statistics, but they represent the population. So yeah, I think I was just trying to make the analogy with the statistical notation. Trying to make it simple for 3106. Okay, so it's 11:36. What else can I tell you? Okay, let me take your questions. Where did you guys get stuck? Did anybody get stuck making calculations? Were people able to get this? So this is for you. I leave this for you to work on, okay? And maybe, let's see if there's a mention in the chat. What are you saying, Jorge? There's some documents. Where? In my
No, I was asking if there was some documents that shows the steps to calculate the parameters.
I'm just
Lower
showing you
column.
now.
I
And
didn't.
the documents are here. This is what I showed you, yeah. This is the documents, how to get it manually. To enter it into the calculator, that's basically what I showed you right now. You guys can review the video. I'll put it online.
Oh, okay.
Yeah, there's not just basically what I'm showing you right now. That's the document. And these are the written formulas also, but then I showed you how to put it into your BA2 your Texas Instrument calculator, BA2 plus. So once you get the variances, then you can get the covariances. And then from there, it's just you use covariance and the variances. And here you use the correlation and so once you get these 3, you got the rest of them. Mean, standard deviation, and covariance. You can do everything. So practice that. So also on the platform, the review exercise is that you can start. Let's see if you can start this one. No. If you're having problems, do not delay. Make a meeting with me. We can have a virtual meeting. We can go step by step. Do not waste any time delaying this because statistics is assumed. I'm assuming after today, I'm assuming you know how to do this. Okay. Where was I? Okay, I was looking for statistics review. Okay, here, review 1, solutions. I think. Let's see what's here. All right, so you get to make some calculations. Oh, here. So you should be able to do all these. Now notice I start calling things with finance notation, even though the two documents that, well, the document ex post and ex ante examples that I gave you was using financial data, but I did not put the formulas into financial notation. I honestly don't care if you use the financial notation, but I need to tell you about the financial notation. So here is the financial notation. So this is the same data set here, you see? But I just call it RM instead of X, and I call this RI instead of Y, and it's RM because it's returns to the market, and it's RI because it's returns to the stock. So I is just whatever stock, in this case BCE. And these crazy looking formulas are the same thing. This is just what? What is this? Somebody tell me that I highlighted.
That's the mean.
That's just the mean. And what's this?
Standard deviation.
Standard deviation. Now notice I use a bar and I use a hat because this is just a sample. This is a sample. It's ex post data. And it's just a sample. It's the same numbers. I'm just showing you the different notation. They put a hat on because it's an estimate, but they use the Greek letter. So some books do it this way. Some notes you'll see this way, but you know this is a sample standard deviation. That's in words, this is called the sample standard deviation. What is this called?
That's R, isn't it? No, wait. No, that's not R. Is it the weight? No,
Look
that's
here,
not.
Yadiam. What does it say? What does it say?
It's the covariance.
That's the covariance. That's the symbol for covariance.
Oh,
Rather
so
than
it's
X and Y, X is the market. Oh, it should be M. It should be MI, but because statistics often does things in alphabetical order, they write the IM. It doesn't really matter if it's IM or X, MI. M for market, I for what again? The stock, right? So this is just a notation you might see. I'm just throwing it in here. It looks really bad. There's lots of things around here, but all you need to think about is it's the same as what we just did over here. Wait, go back to over here. So always use these, not this. Sorry, let me do it again. I recommend you just keep this document or these formulas on your formula sheet. just remember, all you have to do is use these formulas and remember X is always the market. Y is always the stock. And then you don't have to have any worry about any other notation, any other formula. All right, that's my recommendation because these ones are easier to understand. Do I ever expect you to write these out with all the subscripts and things? No, I do not expect it, but you need to communicate to me. So if you're going to write, you have to write like sigma X, sigma Y, of course. But I always stress that when you solve your test, that you get no points for writing down the formula, okay? You get points for putting the values into the formula. So you never really have to write this again. Just put it on your formula sheet and then use it. You're going to just use it, putting the values inside. And when I talk about putting the values inside, I mean, like this. So you guys, I've given you 2 classes on statistics in finance. And from this moment forward, I'm going to assume you guys know this stuff. So practice, okay? And don't be intimidated by this crazy looking formula. It's very simple. This is just the slope. Oh, I guess that's one more thing I have to tell you before we go, because we do have 5 minutes, about the slope. There's 2 formula for the slope. 2 formula for the slope. Let's go back to my platform. I mean, my iPad. If I haven't lost you yet, and even if I have lost you, let's go back and look at the slope. So let's go where we were happy over here. And here's the slope formula. And I told you we could find the covariance from R, SX, SY, right? This relationship here can be used I can use this relationship. So I just took this one, I rearranged to get covariance. What if I wanted to write this in terms of covariance, not R? How can I do it? What would the formula be? If I wanted, instead of R, I want covariance. What would happen to the formula? So in this case, I rearranged to find covariance. But what if I put this into here? How would the formula change? Does everyone see what I did? So there's going to be 2 formulas for the slope. This is the one you're going to use most of the time, but sometimes you might see this one. I want you to, before we go, we have a couple minutes. I want you to do this. Wait, first of all, did you follow what I did here? I just substituted this for R. And then I canceled because these cancel and I combine these. So this is the variance. So really, the slope is covariance divided by variance of X. So it's looking at the covariance for every unit of variance in X in the market returns. So it's relative to the market returns, this measure here. This is what we interpret it as. Okay, so it's how it co-varies relative to every unit of the variance in market returns. So I want you to do the same thing for the slope of ex-ante data. And that's where we're going to start next class, okay? So I want you guys to try review 1 before next class, question 9. And do your best at calculating all those statistics for practice, okay? And learn how to use your calculator, review this video, and let me know if you're really stuck. I want to keep in touch with you. Don't want to lose you at this point. You work too hard. So do review 1 on the platform, question number 9. And tell me the second formula for beta. You're going to substitute this in and give me a second looking formula so you can practice those symbols. All right. So have a good day, and I'll see you on Thursday by 11:35. We're going to start. Okay. Questions, comments?
Thank you, Professor. Have a good day.
Bye, Saina. Bye. Thank you.